Hello, geometry students. In this video, let's take a look at our 7.5 notes, parts of similar triangles. So we're going to start with this first theorem that talks about special segments of similar triangles. And just a quick reminder, we have studied three different kinds of special segments of triangles. We studied altitudes. Those are those segments whose endpoints are a vertex of a triangle and a point on the line containing the opposite side, where when you draw that segment, the segment is perpendicular to the opposite side. And then we talked about angle bisectors, and an angle bisector, of course, is a segment that bisects an angle of a triangle. And then medians are segments whose endpoints are a vertex of the triangle and a midpoint of the opposite side. So those are those special segments of triangles, and let's see about their relationships with similar triangles. So the theorem says if two triangles are similar, then the lengths of their corresponding special segments are similar to the lengths of their corresponding sides. So let's start with this first example. We have a couple of triangles that we are told are similar, and then each triangle we have an altitude drawn. So let me just highlight those altitudes. Let me highlight them in yellow. Okay, and then let's write, since those altitudes are proportional to any pair of corresponding sides, then let's write a proportion. Let's start with, let's look at side AB, which would correspond to FG. If you look at the similarity statement, notice that notice that AB is the second two letters mentioned in the name of this first triangle, and FG is the second two vertices named in the second triangle, so they for sure correspond. So since those parts are proportional, we can write a proportion and say that the ratio of AD to FJ, now that's the ratio of the altitudes, is equal to the ratio of those green segments, which would be AB to FG. And along with that, let me highlight another pair of corresponding segments. How about, let's make it blue. How about CB and HG? And again, we know that they correspond because CB were the first and last vertices named in the first triangle, and HG are the first and last vertices named in the second triangle. So we'll write the ratio of, CB to HG. And then that ratio is equal to the ratio of the unmarked sides, and that would be AC to FG. AC to FG. All right, so if we have two triangles that are similar, then the ratio of their altitudes would be equal to the ratio of any two corresponding sides. Okay, so let's move on to angle bisectors. And the first thing we need to do is, I have a typo here, so I copied and pasted and made an error. So if you could mark this out, the similarity statement should be that triangle KLM is similar to triangle QRS. Sorry about that mistake. Okay, so in this instance, we have a pair of angle bisectors that are similar. We're going to compare the ratio of the angle bisectors to the ratio of any two corresponding sides. So again, I'm going to go ahead and highlight those angle bisectors in yellow, and then let's pick a pair of corresponding sides. How about we'll pick LM and RS, and I know that they correspond because LM would be the last two letters, last two vertices named in the first triangle, and RS are the last two letters named in the second triangle. So we can take the ratio of those medians, that would be LP to RT, and that would be the same as the ratio of those green sides. And make sure we go, notice we went smaller altitude to larger altitude, so we want to take the smaller corresponding side to larger. So LM to RS, LM to RS which would be equal to the ratio of another pair of corresponding sides. Let's highlight, how about blue? Okay, sorry. So let's highlight these pair of corresponding sides. So the ratio of the angle bisectors would be equal to the ratio of those corresponding sides. So KM to QS which would be equal to the ratio of the sides we haven't marked yet. So that would be KL to QR. All right, and then the last part of this theorem talks about medians. The ratio of the medians would be equal to the ratio of any corresponding sides. So let me highlight those medians in yellow, okay? And let's write the ratio of those medians. The ratio of the medians would be CD to YZ, and that ratio is equal to the ratio of any two corresponding sides. Let's start with AB to WX. Let's write that ratio first. So AB to WX, which is equal to the ratio of, let me see, let me highlight a different color. How about blue? Let's highlight CB to YZ. I know that they correspond because CB were the last two letters, or last two vertices named in the first triangle, and XY or YX are the last two named in the second triangle. So we'll write that ratio, CB to YX, which would be equal to the ratio of the unnamed sides. That would be AC to WY. All right, so let's use this theorem then to solve some equations. So in this first example, it says find the value of x in each of the following, and we're given the similarity statement that triangle ABC is similar to triangle FDG. All right, so we'll also notice that we have some special segments, and since we're looking at these arcs and these arcs, the special segments that we're looking at would be angle bisectors. So let me highlight those in yellow. Now, the ratio of those angle bisectors would be equal to the ratio of any two corresponding sides. So I'm predicting that, let's see, that side AB is going to correspond to side DF, since those are the sides that we had measures for. But let's just double check. Let's look at our similarity statement. Notice that AB, first two vertices named here, FD, first two vertices named here, so we know for sure that these blue sides correspond. So we can write a ratio and say that the ratio of the angle bisectors, so that would be AP to FQ, is equal to the ratio of the blue corresponding sides, so that would be AB to FD. Now let's go ahead and fill in the measures and the unknowns, and then we can solve for that. So in other words, AP is X, FQ is, FQ is 8, and that is equal to the ratio of AB, which is 15 to 12. All right, so once we have that proportion written, then we can cross multiply, and those cross products are going to be equal to each other. So we would have, we would have 12x is equal to, 15 times 8 is 120, and then divide both sides by 12, x is equal to 10. Now, what did the directions say? The directions said find the value of x, so we are done with part A. So let's move on to part B. Here, we need to finish the similarity statement. The first triangle is named KML, and then we need to decide if KML is similar to this triangle. Well, I see one pair of angles marked congruent and then a second pair of angles marked congruent. So that's enough by the angle-angle similarity postulate to guarantee that the triangles are similar. So let's finish the similarity statement. K, which has one, K, which has one arc, would correspond to X that has one arc. And then, oops, I meant to do that in blue. Okay, and then, M has no arc, and so it would correspond to Y. And then L, which has two arcs, would correspond to Z. All right, so now let's write a proportion. Notice that we are given the altitudes, so I'm going to highlight those in yellow. Those altitudes would be similar, the ratio of those altitudes would be equal to the ratio of any two corresponding sides. So looking at the sides that we are given measures for, KM and YX, let's make sure that they correspond. Notice that KM are the first two vertices named in the first triangle, And XY are the first two vertices named in the second triangle, so they definitely correspond. So we can write a proportion. We can say that the ratio of those altitudes, which would be 16 to x, is equal to the ratio of the corresponding sides, which would be 20 to 15. So at this point, we would cross multiply and get, let's see, 20x is equal to 16 times. Oh, you know what we might want to do? A good idea whenever you're solving proportions is if you can reduce a ratio, reduce it. Let's rewrite this proportion as 16 over x, and then I'm going to rewrite 20/15ths, since I have a common factor of 5, as 4/3. Now that you have smaller numbers to deal with. So now when we cross multiply, we would get, let's see, 4x is equal to 16 times 3 is 48, and x is equal to 12. And then again, since the directions just said to find x, we are done with part B. So let's move on to part C. And again, we need to finish the similarity statement. Okay, so the question is, do we have enough information to determine that the two triangles are similar? Well, I see one pair of angles here that's marked with double arcs. Now, if you look really closely, there's some, let me maybe make this a little bit darker. There's an arc here and an arc here. So there's a second pair of angles congruent. So by angle-angle similarity, those two triangles would be similar. So RST would be similar to, well, R, notice, has no arc, so it would correspond to U. And then S, that has two arcs, would correspond to V, that has two arcs. And then last but not least, T, that has one arc, would correspond to W. That corresponds to W. Okay, so now notice we are given these segments that go from a vertex to the midpoint of the opposite side. We're given the medians. So I'm going to highlight those in yellow and recall from our theorem that the ratio of those medians would be equal to the ratio of any two corresponding sides. And then since these segments are medians, and we've got these tick marks that show us that if this measure is x, this measure is x. So I'm going to go ahead and mark that as x. And then again, the tick marks in this triangle tell us that if UQ is 3, then QV is also 3. Okay, so as we go to write our ratio, we'll write the ratio of, oh, and those sides, let's take a look. Let's see if SR corresponds to UV. Well, SR or RS are the first two vertices named in the first triangle, and UV are the first two named in the second triangle. So those sides definitely correspond. So we can write a ratio or a proportion that takes the ratio of the medians, which would be 13.5 to 9. That would be equal to the ratio of those corresponding sides. So this entire side, if you use your segment addition postulate, we would call this side 2x. And then the corresponding side in the other triangle would be 3 plus 3, which would be 6. All right, so then let's cross multiply. We would get, let's see, 18x is equal to 13.5 times 6 is 81. And then we'll divide both sides by 18, and we'll get that x is 81 divided by 18, which reduces to, let's see, there's a common factor of 9, so that would reduce to 9/2. All right, so now let's take a look at a second theorem of the day. And this one is called the triangle angle bisector theorem. Let me see if I can get it on the screen here. Okay, and here's what this theorem says. It says, an angle bisector in a triangle separates the opposite side into segments that are proportional to the lengths of the other two sides. So that's a really wordy theorem, but as we look at this diagram, I think it'll make sense to you. Okay, first of all, here's an angle bisector. See the arcs here, so we know that JM is an angle bisector. Okay, now that means that the angle bisector would intersect the opposite side, which cuts it into these two pieces. Now what the theorem is telling us is that these two pieces are going to be proportional to two sides of the triangle. So what I like to do is I just like to draw arrows. I like to say that the ratio of KM to this piece would be the same as the ratio of LM to this piece. So in other words, let's rewrite this theorem in terms of this diagram. So the hypothesis tells us we have an angle bisector of a triangle which separates opposite sides into segments that are proportional, or into two segments. So our hypothesis just tells us that segment JM is an angle bisector of triangle JKL. So if it's an angle bisector of triangle JKL, then what it's doing is it's cutting this opposite side into pieces that would be proportional to the other two sides of the triangle. In other words, the ratio of, let's take KM to KJ. Okay, so the ratio of KM to KJ would be equal to the ratio of ML to LJ. So that would be ML to LJ. Now, since we're coming up upon Valentine's Day, I like to, if I could take this and rotate it, that kind of looks like a heart, doesn't it? So you can think of this as the heart theorem. All right, so let's use that theorem then to solve a few examples and we'll be done. So example A says, and in this example where we are told to find the value of x in each of the following, notice that we have an angle bisector. Okay, this segment RT is an angle bisector. So what that means is it's cutting the opposite side into segments that are proportional to the other two sides of the triangle. Okay, so in other words, the ratio of x to 6 would be equal to the ratio of this piece right here. Now, we're going to have to write an expression for this piece in terms of x. All of QS is 18, okay? Now, if we take the whole length of QS and subtract x from it, that would give us this piece. So we would say this is 18 minus x. So to finish our proportion, we're going to say that this 18 to x, we're going to write a ratio of it to 14. So that would be, let's see, 18 minus x to 14. All right, so let's cross multiply. Now, when you cross multiply this way, you might want to put some parentheses around this binomial so you remember to distribute. So we'd have, let's see, 6 times 18 is 60 plus 4 is 108. So 108 minus 6x would be equal to 14x. And then let's quickly solve for x. So 108 would be equal to 20x. We'll divide both sides by 20. And so we get 108 over 20, which reduces, let's see, there'd be a common factor of 4, and it would reduce to 27 over 5. And we can just leave our answer like that. And since all we were asked to do is to find x, then we're done. Okay, so let's move on to letter B. So again, we have an angle bisector. So we have an angle bisector. That angle bisector is cutting this opposite side into segments that are proportional to the other two sides. So in other words, we can write a ratio that compares 4 to x to the ratio of 6 to 13. So let's go ahead and write that proportion. We can say 4 over x is the same thing as 6 over 13. We'll cross multiply and get 6x is equal to 52. Yeah, 4 times 13 is 52. Divide both sides by 6, and we would get x equals 52 over 6, which we could reduce that. They're both even, so we could reduce that to 26/3. All right, and let's do one more example. Again, we're going to have to write an expression for this piece right here, okay? This whole opposite side is 20, so if we subtract x from it, we'd have an expression for this piece. So that would be 20 minus x. So now we'll write a proportion that compares the ratio of 20 minus x over 11 to the ratio of x over 14. So that ratio would look like this. 20 minus x over 11 is equal to x over 14. All right, and then we'll cross multiply. Let's put parentheses around this binomial so we remember to distribute. So when we cross multiply, 14 times 20 is 280, and then minus 14x is equal to 11x. And I'm going to add 14x to both sides and get 280 equals 25x. Then we'll divide both sides by 25, and that reduces to, let's see, there's a common factor of 5. Yeah, common factor of 5. So that's going to reduce to 56 over 5. And then the direction said to find x, so at that point we're done. All right, so I'm going to wait and post this homework tomorrow. We will be doing this homework tomorrow in class. So if you have any questions about these notes, make a note of it and be sure and ask me when I see you in class next time.